Okay, all of you. So time taken for P to reach the maximum height. Of course, time taken to reach the maximum height is simply U over G, because at the maximum height, final velocity is 0. Okay, so 10 meter. Okay, speed of. Okay, so 10 meter divided by, we are also asked to take G to be 9.8. So what is 10 divided by 9.8? Of course, 1 point something. That's 1 point what? 10 divided by
1.02.
1.02. Thank you. So it will take P this time to reach the maximum height. Then from the maximum height, so from the maximum height to the ground, we will need that maximum. Okay, we will need the maximum height traveled, and that will also be H is equal to U squared over 2G. Okay, so 10 squared divided by 2 times 9.8. 10 squared divided by 2 times 9.8. I'm waiting for you, please. Let's hurry up.
5.10.
5.10 meter, meaning the maximum height that will be taken by P to reach the maximum height traveled from the point of projection of P and Q would be 5.1. So if P gets to the maximum height, of course, it must drop to the ground. Okay, so let's then determine the time taken for P to move from the maximum height back to the ground. And when P, this is falling from this time around, it is free falling. So using H is equal to UT plus half JT squared, H will be equal to 5.10 plus 100. So the total height from the maximum height to the ground, this whole height will be 5.10 plus 100. So 105.1. Okay, will be equal to, since it is free falling, initial velocity is 0. So half times 9.8 times t squared. Okay, so we'll have t squared giving us 2 times 105.1 all divided by 9.8. Quickly calculate this for me. 2 times 105.1, then you divide that by 9.8.
Me and you.
Come again.
21.44.
21.44.
45.
Okay.
Sorry, it's 45.
Is that the whole product of the numerator and then divided by the denominator?
Yes, please.
Okay, therefore, t is equal to the square root of 21.45. Square root of 21.45. This must be 4 point something.
4.63.
4.63 seconds. So it means that it will take P this time to move from the maximum height to the ground. Therefore, the time of flight of P, which is the total time of P would be equal to the time taken to reach the maximum height, which is 1.02 plus 4.63. Put that together for me.
5.65.
5.65 seconds. So this will be the time. Yes, thank you. This is the time that will be taken for P to move from the point of projection to the maximum height and fall to the ground. Please, is that understood by all?
Yes, sir.
All right. Then let's look at the time taken for K to also drop to the ground. So for K, don't forget, while Q is projected vertically downward with the same speed. So it means that Q is not free falling. It has an initial velocity also equal to 10 meters per second with the same speed. Okay, so H equal to UT plus half GT squared. H is 100. Is equal to 10T plus half times 9.8 T squared. Okay, so we have 10T plus, what is 9.8 divided by 2? We have 4.9.
4.9.
So 4.9 good, T squared. Let's equate, we can divide through by 10. When we divide through by 10, this is 10 is equal to T plus 0.49 T squared. If we equate everything to 0, we'll have 0.49 T squared plus T minus 10 is equal to 0. Plus, are we okay?
Yes, sir.
Good. And when we compare this to a general quadratic equation formula, we have a general quadratic equation formula with ax squared plus bx plus c is equal to 0. Here our variable is t, so we can also write it as at squared plus bt plus c is equal to 0. So that when we compare, A will be equal to 0.49, B will be equal to 1, and C will be equal to -10. So we can use almighty quadratic equation formula. T would be equal to minus B plus or minus square root of B squared minus 4AC all divided by 2A to find the value of T. So T will be equal to -1. Don't forget B is positive. So because there is minus here, that will be -1 plus or minus square root of 1 squared is the same as 1. Minus 4 times A is 0.49. C is minus 10. All divided by 2 times A. Plus, are we okay? Are we okay to this point?
Yes, sir.
All right, then
Yes, sir.
let's find the value of T. Under the root sign, we'll have 4 times, multiply 4 times 0.49 times 10. 4 times 0.49 times 10. Do that for me. Don't forget we'll have positive.
19.6.
Okay, 19.6. So we have 19.6 under the root sign, all divided by 4 times 0.49. Sorry, 2 times that.
0.98.
Okay, so let's find the square root of 19.6. That will be 4 point. Square root of 19.6.
4.43. 4.43.
Okay. Charles.
Sir,
Charles, your hand is up.
sir,
I'm listening.
sir, please. With the calculation, we left the 1 out. It should have been 1 plus 19.6.
Oh, yes. Thank you, Charles. 1 plus, yes. Class, do you see that 4 times 0.49 times 10? I guess that is giving us a 19.6. Is that correct? Let's confirm what Charles is saying. 4 times 0.49 times 10. Good. Thank you. So there should be, we should have added that to 1. We omitted the 1. Class,
Yes, sir.
please, do you see it?
Yes, sir.
All right. Charles, thank you so much. So that's why we must all be involved in what we are doing, okay? So that if there is something wrong somewhere, we can all see and then draw the attention of the teacher. All right. So 19.6 plus 1, okay? And that must give us 20.6. So we rather take the square root of 20.6, which will still be
4.53.
divided by 0.98. Now we throw out the negative because we don't have anything like negative time. So ideally the value of T should be -1 plus 0.4 4 point, I'm coming, -1 plus 4.53 divided by 0.98 or -1 minus 4.53 divided by 0.98 because it is plus or minus. But since we don't have anything like negative time, we'll ignore the negative and only consider the positive. So class, this is the reason why we are throwing away the negative part of the quadratic formula. So we use T is equal to 4.53 minus 1 all divided by 0.98. So subtract 1 from 4.53 and that will be 3.53. Divide 3.53 by 0.98. Yes, 3.53 divided by 0.98. Well, where are you?
Yeah, solving it.
Oh, just divide 3.53 by 0.98.
Yeah, please. 3.6.
3.60.
Good, seconds. I last time told you that when the calculator gives you that lengthy value, just express your answer in 2 or 3 dp's. You don't need to write everything. Okay. So this is the time taken for Q to also drop to the ground. Therefore, the time interval between Q and P would be time of P, the larger minus the smaller. Okay, and P gave us the larger time because of its trajectory or path, 5.63. So 5.63 minus 3.60, and the difference would be 2.03 seconds. That is the solution to the question. And some of you actually forwarded your answers to me, even though I asked you not to. But some of you did that, and I took time to look at it for them, and you got it spot on. Class, is there any question to ask? Because I'm going to give you a similar one to try your hands at. I think I even sent the question to some of you. Those of you who submitted your work, because I realized you had done that, I forwarded the question to some of you. So I'm going to place it on the page for all to look at. Then right after this, I think we'll look at another area. So let me see how you can effectively apply solution to this question to solve this one. To try me. Please, the question is on the page. From the top of a tower from the top of a 30-meter high cliff, from the top of a 30-meter high cliff, a stone is dropped. At the same instant, another is projected vertically upwards from the ground. At the same instant, another is projected vertically upwards from the ground with a speed of 30 meters per second. After how much time and at what height? After how much time and at what height from the ground will the two stones cross each other? So it's a two-in-one question. We are looking for the time taken for the two stones to cross each other, and then the height, and the height where the two would also be crossing each other. So class, this is your problem of the afternoon. I'm giving you 10 minutes to think through this, to solve it, okay? After which we will discuss and then move on. Is there any question? Esian? Manuela?
Could you please repeat the question?
Hey, Emanuela, I will do so, but the question is on the page. I just dropped it on the page. So you can go back to look at it. Please, I'm going over the question. From the top of a 30-meter high cliff, a stone is dropped. From the top of a 30-meter high cliff, a stone is dropped. At the same instant, another is projected vertically upwards from the ground with a speed of 30 meters per second. After how much time and at what height from the ground will the two stones cross each other? Okay, so if you ask, this is the question. So your 10 minutes starts from now. It's 2 to 2 minutes past 2 o'clock. So start work. And this is NSMQ, problem of the afternoon. I want to take attendance, so.
Don't drop from the plane. Besides other states, acceleration, height, the height from the stone protected. These are those We need a equation.
Please, you can discuss it among yourselves, okay? Maybe you can do the discussion on the page. But you have 10 minutes to do this. Yes, take J as 10. Thanks for the reminder. Take J as 10. You've done 5 minutes. You have done 5 minutes.
Using the equation. AI.
Please do not use AI to solve this. So, yes, if you do that, AI will solve it for you, but you will not understand. We are applying all that we've learned under vertical, upward, and downward motion in solving the question. So just let's apply, okay, let's apply the concepts, or the key parts of whatever we've done to solve the question. When you use AI, yes, it will solve it for you, but you will not understand. And at the end of it, but you will be at the losing end. So please. You have 3 more minutes to go. 3 more minutes. So the height of the cliff is 30 meters. So let's use this to represent the height of the cliff. An object is dropped from the top of the cliff. Simultaneously, or at the same time, another is projected. So we have another being projected from the ground with a velocity of 30 meters per second. So the velocity of projection of the other one, U, is 30 meters per second. After how much time and at what height from the ground would the two cross? So when this one is dropped, this will be the direction of its flight, vertically downwards. Whereas this is also moving in that vertically upwards direction. So this is the direction of the other one. Supposing if they cross, if this meets or crosses the other one at a height h from the ground, I mean the second stone, if it meets this one at a time at a height h from the ground, then the first stone would travel by then would also, so let's assume they are all meeting at this point. The second one is meeting the first one at h, a distance or a vertical height of h from the ground. Then by then the first one will travel 30 minus h. Go from where it is to the ground is 30 meters. So if it is, the second one is meeting, this is the second stone, the first stone. If they are meeting, if the second one is meeting the first one at a height h from the ground, then the second one, the height, vertical height traveled by the first one will be 30 minus h. Class, are we okay?
Yes.
So equation
No,
of the,
No,
all right,
sir.
so you see, the whole height of the cliff is 30, and this is the first stone. So from the ground to where the first stone is, this distance is 30. Then the second stone is just projected from the surface of the ground. So the ground is here. Supposing they are all meeting at this point. So first stone has fallen to this height, and the second stone has also fallen, been raised to this height. So this is the first, this is the second. And before the two stones meet, if the second one has traveled a height of 10 meters from the ground, what will be the vertical height traveled by the first? by the time they meet?
10 meter.
Come again.
10 meter.
Look at it again. The position of the first stone from the ground is, the initial position of the first stone from the ground is 30. So 30 meter.
20 meter.
Okay, so as at when the two stones meet, the second one has moved a vertical height of 10 meter from the ground. We are taking our measurement from the ground. So if it has gone 10 meter from the ground, what will be the vertical height traveled by the first from its initial position?
20 meter.
Please, those of you who responded, you don't understand, please, are you following? Camila?
Yes, sir.
Sir,
Camila?
please, the height
15
meters.
Come again.
15 meters.
No, listen to the question. From the top of a 30-meter high cliff, a stone is dropped. So the first stone, its position from the ground is on top of the cliff. So its position from the ground is 30 meters above, okay, or from the ground. Camila. Pascaline.
They said 20 meters.
Yes. So I'm referring to those who responded. They are not so, they do not understand. Please, do you understand now?
Yes, sir.
So if second stone is, by the time they meet, has traveled h meter from the ground, then the first stone will travel 30 minus h. It's the same as you got 20 because you subtracted the 10 from 30. So 30 minus 10. Here I'm representing the vertical height by the time they meet by h. So if this is h meter from the ground, then by then the first one would have traveled 30 minus h. Can I continue? Class, can I continue?
Yes, sir.
All right.
Yes, sir.
Yes, sir.
All right.
So
Raman,
please, I don't.
Abdul,
Yes, sir.
what's the problem?
Hello, sir, please, can you hear me?
Yes, I can hear you. Do you understand?
Yes, sir.
All right. So let's
I
write
don't.
and you see, so all that we are doing is that if the second stone moves a vertical height of h from the ground, okay, then the first stone by then would have traveled 30 minus h from the top of the cliff. So that's why I use number. Supposing this has traveled 10 meters above the ground by the time they meet, then the first one will travel 30 minus 10. But I'm only using letter H. Okay. So equation for the first stone,
Okay.
for the first stone.
Hello, sir.
Hello, Darius.
Hello, sir.
Hello.
Sir, please, I'm saying.
Darius, I'm listening.
Sir, please. Okay, sir, please, I'm saying that what you're trying to say here is that so you are taking the 10 there as like an assumption.
Exactly. It's an assumption. Okay. But the vertical height where the two stones would actually meet, we don't know. That is why I'm representing that by H. Okay. So if by the time they meet, the second has traveled H meters from the ground, then the first will travel 30 minus H. The 10, I use that as an example. All right. So for the first stone, you see, it is free falling. And if it is free falling, then the initial velocity will be 0. So each vertical height traveled by the time they meet is 30 minus h. 30 minus h will be equal to half times j is 10, t squared. So we have 30 minus h is equal to 5t squared. This is equation 1. Then for the second stone, by the time they meet, we are also assuming that the time where the two would meet is t. The second stone, it's moving up with an initial velocity. So h would be equal to ut plus half jt squared. So h is the unknown vertical height, is equal to, it is going up, the second stone is going up with an initial velocity of 30. So 30 t plus half times 10 t squared. So this is 30 t plus 5 t squared. So we have this equation, this as equation 2. So basically we have equation 1 and then equation 2 to solve them simultaneously. Equation 1 is 30 minus h is equal to 5t squared. So even if we represent 5t squared by 30 minus h, we'll have equation 2, h is equal to 30 t plus, let's represent 5t squared by 30 minus h. 30 minus h.
30 because half squared.
Or you can solve it. So you have equation 1, 30 minus h is equal to 5t squared. And then equation 2, h is equal to 30t plus 5t squared. Can you help me solve these two equations simultaneously? Help me solve for t. You can substitute equation 1 into 2 or 2 into equation 1, whichever way you want to go. So when you finish, when you get the value of t, then you can find the value of h. Please, are we done? Class, are we done? Oh, where are you people? I asked you to solve the two equations for me. What is your value of t? Pascaline and the rest of you, what did you make for t? Oh, the line is breaking. Yedidiah, what did you make for T?
Yeah.
Uh-huh.
For the first equation,
Solve the two equations simultaneously. What did you make for T?
okay, sir.
Did you get T to be equal to 1?
Yes, sir.
How many of you are getting T to be 1? Raise up your hand if you are getting T to be equal to 1. Okay. Okay. So that is it. So 30 minus h is equal to 5t squared. And then h is equal to, oh, you see, there is a mistake. No, the second stone is moving up, so it must be minus. This must be negative, not plus. And nobody also drew my attention. This must be minus because it's a vertically upward motion. The body will decelerate. Please, are we okay? Class, are we fine?
Yes, sir.
Yes.
So if this is equation 1 and this is equation 2, you can then easily substitute. If you want to substitute equation 2 into equation 1, we have 30 minus 30t minus 5t squared is equal to 5t squared. When you substitute equation 2 here, okay, so 30 minus 30t plus 5t squared is equal to 5t squared. 5t squared will go to 0. And 30, when you send, please mute yourself if you haven't. Hello. Oh, let me mute all. So 30t would be equal to 30, so that t is equal to 1 second. Please, if so, it means that when both are dropped at the same, one is dropped and the other is moved up at the same time, they will all cross each other or meet when at a time t is equal to 1 second. If t is equal to 1 second, what will be h? The vertical height h, where the two stones will cross or will meet one another. Substitute 1 second into any of the two equations, either equation 1 or equation 2. If you use equation 1, we have 30 minus h is equal to 5t squared, and t is 1. Okay, t is 1. So if you make h the subject, h will be equal to 30 minus 5, and that will be 25. Pascaline. Okay.
Yes, I was trying to tell it.
Okay. So that will be 25. So whether you use equation 1 or equation 2, you must have the same answers. Please, class, is that understood? Can we move on? All right.
Yes, sir.
Let me give you one. You solve it after the class and send to me. A boy on a 20-meter high cliff. A boy on a 20-meter high cliff drops a stone. A boy on a 20-meter high cliff drops a stone. One second later, he throws down another stone. 1 second later, he throws down another stone. Both the stones hit the ground simultaneously. Both the stones hit the ground simultaneously. Find the initial velocity of the second stone. Find the initial velocity of the second stone. Take G to be 10 meters per second squared. I'm going over. A boy on a 20-meter high cliff drops a stone. The first one is drop. 1 second later, he throws down another stone. 1 second later, he throws down another stone. So the second situation is a throw. Both the stones hit the ground simultaneously. Both the stones hit the ground simultaneously. Find the initial velocity of the second stone. Take G to be equal to 10 meters per second squared. So that is your take home. That's your assignment. Projectile motion. So projectile motion, let's probe what is a projectile or what a projectile is. So we must understand a projectile. And then we look at projectile motion. Projectile motion, you see, is similar to Projectile motion is similar to motions under gravity, but slight difference. Projectile motion is a motion of a body or an object that is given an initial velocity. Class, give me a minute, I'm coming. So projectile motion is the motion of a body that is given an initial velocity and falls under the influence of gravity, ignoring air resistance. So let me give you the motion of a body or particle that is given initial velocity and falls under the influence of gravity, ignoring gravity and ignoring air resistance. So under this motion, yes, the body must be given an initial velocity because projectile motion, we'll look at applications of them and you see. So the body must be given an initial velocity. The body falls under the influence of force of gravity, but in projectile motion, we always ignore air resistance, meaning air resistance is an enemy to projectile motion. Class, are you there? Are we there?
Yes.
Okay. So that is projectile motion. Then what is a projectile? A projectile is a body. So the projectile refers to the body. A body that is given an initial velocity and falls under the influence of gravity, force of gravity, by ignoring air resistance. So the projectile motion is the motion of the body, and the projectile is the body itself. Please, are we okay?
Yes.
Yes,
Okay.
sir.
Is there any question? Let's then
No,
look
sir.
at examples of projectile motion. Projectile motion. Throwing a javelin. And look at, if you've seen a javelin being thrown before, athletes do not shoot or throw the javelin when the environment is windy. When it is windy, the wind, which is air resistance, would affect the part of the javelin, which the javelin is the projectile. So when it is windy, okay, athletes do not shoot or throw the javelin. 2, firing a missile. Firing a missile. You see, if you have seen a javelin before and a missile, the javelin is just a rigid bar but the edge of it is pointed, shaped to have a streamlined edge. And there is a reason. The reason is that to reduce air resistance. Air resistance affects projectile motion. So to reduce air resistance, it must be given that conical sharpie end so that it can easily pierce in the air and go. The same thing, the same application is also used in missile development. If you've seen this missile before, fired by a cannon, these missiles, whether cannon or by automatic gun, they have a very pointed edge. That is to cut through the air to avoid air resistance. So firing a missile also falls under projectile motion. Then 3, kicking a ball. Okay, in the air. And if you've watched football matches very well, whenever the wind velocity is so much, football matches must be stopped because air resistance affects the motion of the projectile, which is the ball here. Okay, then 4, this game where there's a long stick that is used to hit a ball placed on the ground. I've forgotten the name of the game. Is it hockey? No. Yes, hockey would also be part.
Golf.
Golfing,
Cricket.
and cricketing.
Golf.
So golfing, and even hockeying would also, because in all these instances, it is given
Snooker.
What? Snooker. Okay,
Yes,
even TT, playing of long tennis and all that falls under projectile motion. Okay. Okay, so that is examples of projectile motion. Is there any question? Prince Williams Afid.
Yeah, please. In my seniors were saying that projectile motion, it is hard. Say, please, is it true?
Prince, we are going to, this is a topic we are going to do. So you let's wait. If it's hard, you will see. If it's not hard, you also see. Okay. Prince, are you okay?
Yes, sir.
So once we've started, you let's do it. If it's difficult, you see it. Now, in projectile motion, there's one key assumption. The first assumption in projectile motion is that air resistance must be neglected. Must be neglected. So that is why I said athletes will not fire the javelin when it is windy. Footballers will stop playing when it is raining and the field is so windy, the ball cannot be controlled. Okay, military personnel during battle will not fire a missile when it is windy. They cannot fire to their target. So this is a key assumption that must be considered in projectile motion. And two, the second assumption is that gravity is assumed to be ineffective Zion, are you there?
Yes, sir.
Okay, so gravity is assumed to be ineffective during the horizontal motion.
No.
Motion
Just
of the
one question.
Alexandra.
Hello, sir.
You mute before I mute you. Gravity is assumed to be ineffective during the horizontal motion of the projectile. So these are the two key assumptions in projectile motion. Projectile motion can be categorized into two. So we'll go through all the two. We have one-dimensional projectile motion. One-dimensional projectile motion. Meaning the body only moves along one dimension. And then we have two-dimensional projectile motion. So which one falls under one-dimensional projectile motion? When golfers, hit the golf ball with a stick. Let's create a situation or a scenario. The golf ball is here, and they use their stick to hit this, and it will move through the air and finally drop to the ground.
Okay.
So this is one-dimensional projectile motion. Okay, one-dimensional because the position of the ball relative to the ground, the angle between them is 0. The two are parallel. So initially it will move in this parallel line and finally drop. So it is because it's one dimension because it makes the velocity given to the ball, the initial velocity given to the ball makes an angle of 0 with the horizontal, which is the ground. This is the horizontal. Okay, so in one-dimensional projectile motion, the velocity of projection or the velocity given to the body makes an angle of 0 degree with the horizontal, which can be the ground. Class, are we okay?
Yes, sir.
Yes, sir.
You must understand what pertains in one dimension. Stephanie, are you there?
Yes, sir. Yes, please.
Okay, so in one-dimensional projectile motion, the velocity, the initial velocity makes an angle of 0 degree with the horizontal. Then two-dimensional projectile motion. You see, nobody throws the javelin. They want to throw the javelin and you just throw the missile or the javelin parallel to the ground. It cannot go far. Two, it will not hit and then make contact with the ground. It will fall flat. Nobody fires the missile and then fire the missile to go horizontal or parallel to the ground. If you have watched war movies, whenever missile is being fired, the missile is positioned at an angle relative to the ground, which is the horizontal. So, example, if this is the ground, if this is the ground, if this is the missile or the projectile, example, javelin or the missile, it is always fired in such a way that it makes a certain angle theta with the horizontal. Or if there's the initial velocity given to the javelin or the missile, the initial velocity makes a certain angle theta with. And that is why when you are throwing the javelin, you must hold the javelin grip it, and then throw it at an angle to the horizontal. You don't throw it straight. Class, do you understand?
Yes, sir.
Golfers, and even during playing of TT, if you want to hit the TT ball, in order not to catch the net, you must hit the ball at an angle. Those of you who are good in playing TT, use backhand and this cleft thing just to give it, okay, that velocity which can easily swerve the net and equally swerve the opponent. So where the projectile makes an angle relative to the horizontal, it strictly falls under two-dimensional projectile motion. Pascaline, are you there?
Yes, sir.
So, what's the name? Jeremiah. Isaiah. Hey, I say Isaiah. Jeremiah.
Yes, sir.
In your own words, what is two-dimensional projectile motion? In your own words, what is two-dimensional projectile motion? Just in your own words, based on all that the information I gave, what is two-dimensional projectile motion? Okay, I'm sure Jeremiah is engaging the brain. Can somebody share with us what two-dimensional projectile motion is based on the explanation? Anybody? Oh, everybody is quiet.
So we are trying.
Try, yes. I say in your own words.
Two-dimensional.
Projectile motion.
The motion.
Not in, just put few words together. What is the key fact which will distinguish it from the one dimension? Manuela, Essien. Emmanuela Essien.
In a two-dimensional motion, the initial
In a
velocity makes an
two-dimensional
angle
projectile
theta
motion.
Anyway.
projectile motion.
Okay, so the
The
initial velocity
makes an angle.
okay. Yes, so there is an angle. The initial velocity makes an angle with the angle theta, or a certain angle with the horizontal. Okay, whereas in one dimension, there is the angle between the initial velocity and then the horizontal is 0. So let's go into one dimension. We are looking at both of them. Let's now start with one-dimensional projectile motion. So in one dimension, if this is the horizontal or the ground, the projectile must be such that if it's here and h is the height above the ground. Abdul Rahman, have I instructed you to be underlining my? So if h is the vertical height from the ground, the body is given an initial velocity, and when hit, its trajectory or path is like this. It will move and then finally drop to the ground. Okay, so this is the initial velocity given to the ball. Now let's follow the path of the ball. So the golf stick gives it the initial velocity. It will move through the air and then would eventually fall to the ground. And that is what I've designed here. But it is one-dimensional because the initial velocity is 0, makes an angle of 0 with the horizontal. So supposing during the path or flight of the body, this is its initial point. Then the second position,
You became king. You're blue chum.
Then the third position, and is finally here, finally drops to the ground. Okay, we want to look at how we can calculate the height, edge velocity, and all that. Now, as I said, in projectile motion, air resistance is ignored. The assumptions. Air resistance is ignored. 2, gravity does not affect the motion of the object horizontally. Air resistance ignored. And then gravity does not affect the motion of the body horizontally. Because of these two reasons, in projectile motion, the horizontally, the velocity is at every point is constant. So U. Horizontally, the horizontal velocity is always constant. Now, you see, the body when hit would go horizontally, then gradually will be dropping to the ground. Okay, so its velocity will be divided into two components, the constant horizontal velocity and then the vertical velocity. Because it has a vertical velocity, that is why it is constantly brought to the ground. Okay, so whilst the body travels, there are two components of velocities acting on it. A horizontal velocity, which is always constant, and a vertical velocity, which is affected by gravity. So at this point, the velocity acting on the body is u, but as it travels through the air, okay, its velocity will be divided into two, horizontal velocity and then vertical velocity. So I'm looking at position 1, position 2, 3, and then the velocity there. When it finally hits on the ground, the velocity, because it has come to a stop, the velocity is 0. Please, are we okay?
Yes, sir.
So we are going to analyze, determine the position when it is here. This is when it is at 2. X2 is its horizontal distance traveled, okay, with respect to its starting point. It is starting from this point, okay. Now, X2 is the horizontal distance traveled. X3 is the horizontal distance traveled after time. So this is time after time T1, T1, T2, till it hits on the ground. Please note that because of this share, horizontal and vertical share in the velocity and in the distance traveled, in projectile motion, you always be analyzing it in two folds, horizontally and then vertically. So we analyze projectile motion horizontally and vertically. Both velocity and displacement. For both velocity and displacement, and even acceleration and acceleration. So whoever asks the question that your senior said projectile motion is difficult, it is not much difficult, but you must understand this part of it. If you are not able to understand how to analyze projectile motions vertically and horizontally, you will be lost. You will be lost. The horizontal velocity is constant. So supposing we give it an initial velocity of 10. Horizontally, this value of 10 will be there throughout the part till it hits on the ground. So this velocity 10 horizontally would always be there. Vertically, it will change. Okay. And why is the horizontal velocity constant? It is because air resistance and gravity are ignored. Okay. It's because air resistance and acceleration due to gravity or force of gravity does not hold when you are analyzing the motion of the projectile horizontally. That is why the velocity horizontally will be constant. So for projectile motion, the horizontal velocity is constant. It's constant because air resistance and gravity are ignored in projectile motion. So this is the reason why the horizontal velocity is constant. So when the body moves and after maybe T1, the body is now here. If I want to calculate the horizontal distance traveled from its starting point, it is starting from this point. So this horizontal distance x1, I can calculate the horizontal distance. Velocity or speed is equal to distance covered over time taken. So if I make S the subject, S is equal to V times T, meaning x1 would be equal to the constant velocity u, the constant horizontal velocity u, times the time taken to come here, T1. If the body comes to this point and it takes time T2 to come here, if I want to calculate this distance, let's assume this is x3. x3 horizontally would be equal to, yes, the constant velocity u times the time taken to get to that point, T2. Class, are we following? Class, are we following?
Yes,
If it finally drops to the ground and I want to calculate the total distance traveled, the golf ball is hit from an initial point. It traveled through the air and then landed. If I want to calculate the total distance traveled, this total distance traveled is what we call as the range. So the range of the projectile is the total horizontal distance traveled. The range would be equal to the constant horizontal velocity times the total time taken. And this is also known as the time of flight, T. So please note that the range is the total horizontal distance traveled. Please, are you writing that? The range of a projectile is the total horizontal distance traveled. And the time of flight Let me represent the time of flight by capital T. The time of flight is the total time taken. The total time taken. The range is the total horizontal distance traveled. And the time of flight is the total time taken. So the range R is equal to the constant horizontal velocity times the time of flight, capital T. So this is how to determine the range of a projectile. Please, is there any question? We have just 3 minutes to end the lesson. Is there any question?
No, sir.
So, hey, Judah, Lionel.
Yeah.
Mm-hmm.
Please, yesterday I was not present for the class, so I don't understand what you are saying.
Oh, this is a new thing we are doing. Okay.
Okay.
Yesterday's video is on the page. Okay.
Okay.
So next week we'll go into one-dimensional, solve examples. When we go through the theory and we begin to solve questions with them, then you can understand very well. So please, whoever said it is difficult, it isn't difficult, but there are some key aspects you must understand. And when you understand it, it will be, Prince, it will be fine. Are you okay?
Yes, sir.
So we'll continue next week. All right. Class will end here. Please, I've given you assignment. I'll drop it on the page once again. Do it and then send it to me. All right. Bye-bye to all of you.
Bye.